Students, this is Sivakumar, 11th Standard Mathematics, Chapter number 1, continuation of exercise 1.3. Now problem number 10. Function f and g from capital R to capital R, here R refers set of all real numbers, are defined by f of x equals modulus of x plus x and g of x equals modulus of x minus x. Find g composite f and f composite g. In short, we can say g dot f and f dot g. Okay, right. Problem number 10. Here is the function f of x and g of x. To find g dot f and f dot g, first we draw a real line minus infinity to plus infinity. This real line to be divided into two intervals. One is minus infinity to 0 and next one is 0 to infinity. So the given function f of x, has to be redefined first. So look at that, f of x, first one, x is less than 0, full of negative numbers. Here I have excluded the 0 because what symbol here, less than 0. Second interval, greater than or equal to 0, here I have included 0. In any one of the cases you have to include that 0. So here I have excluded, here I have included that 0. So full of negative numbers, here full of positive numbers including 0. Okay. Now here we have f of x. F of x, that is equal to modulus of x plus x. So in this interval less than 0, the modulus of x should be written as minus x and plus x right as it is, that is equal to 0. I'll give an example, after that you can easily understand. Then for x greater than or equal to 0, the same f of x, write modulus of x as x only plus x as it is. So here x plus x, that is equal to 2x. I'll give an example, surely you can understand. Listen, x less than 0, in that case consider any one number, is full of negative numbers only. Okay, I consider minus 3, surely minus 3 will be in this interval. Now substitute x equals minus 3, x should be replaced by minus 3. See, if we replace x by minus 3, minus of minus 3, that is equal to plus 3. What is the value of x? Minus 3. 3 minus 3, that is equal to 0. Okay, even here you can replace, you will be getting 0 only. What is the value of x? Minus 3, right? Modulus of minus 3, that is equal to plus 3 because it is an absolute value. 3. What is the value of x? Minus 3. 3 minus 3, that is equal to 0. So in this interval, what is the value? 0. Okay. Now second interval I consider 0 to infinity. I take one number. I take number 3. 3 is a positive number, correct? Substitute x equal to 3 here. 3 plus 3, that is equal to 6. 2 into 3, that is equal to 6. Now here also we can verify. What is the value of x? What is the value of x? 3. Modulus of 3, that is equal to 3. X value 3. 3 plus 3, that is equal to 6. Okay, understood? Like that, g of x should be redefined. Now g of x, that is equal to, here also two cases, if x less than 0, if x greater than or equal to 0. Okay, here we have g of x. For x less than 0, the modulus of x should be replaced by minus x. Remember, for less than 0 only, in that case only here minus x. This minus x write as it is. So minus x, minus x, that is equal to minus 2x. Next, for x greater than or equal to 0, in this interval, modulus of x is x only, x minus x, x minus x, that is equal to 0. Now we can verify, right? For x less than 0, I take one negative number, full of negative numbers only. I take minus 3. Substitute x equals minus 3. If you replace x by minus 3, minus into minus plus 3. This is plus 3. What is the value of x? Minus 3, correct? Once again, minus into minus 3 plus 3. 3 plus 3, that is equal to 6. We can verify. What is the value of x? Minus 3. Minus 3 into minus 2, that is 6 only. Left hand side 6, right hand side also 6. Even here we can verify. X value we have taken minus 3. Okay, remember. Substitute x equals minus 3. Modulus of minus 3, that is equal to 3 minus x value is minus 3, minus into minus plus 3. 3 plus 3, that is equal to 6. Understood? Value doesn't change. Now second case, here x greater than or equal to 0 means full of positive numbers. Positive numbers, I take number 5. Substitute x equals 5. 5, x value 5 minus 5. 5 minus 5, that is equal to 0. Here also we can verify. What is the value of x? 5. I consider x equals 5 here. Substitute x equals 5. Modulus of 5, that is equal to 5 minus x value is 5. 5 minus 5, that is equal to 0. The value does not change. Now we have redefined f of x and g of x. Now subdivision number 1. I am going to find g dot f first. After that f dot g. G dot f. G dot f itself double case. Case number 1. Right. Now when x less than 0. Second case, x greater than or equal to 0. X less than 0, I am going to find g dot f. First introduce x. That is equal to, this can be written as g of f of x. You are asked to find g dot f. First you have to introduce x. This itself can be written as g of f of x. That is equal to, write g as it is. For x less than 0, what is f of x? For less than 0, f of x. Less than 0, f of x, what is the value? 0. So this can be replaced by 0. Now, what is the function outside the bracket? G. Go to G. Here also have to consider less than 0 only. For less than 0, we have minus 2x. Minus 2x. But what is here inside the bracket? We have 0. Here x, here 0. So x should be replaced by 0. If you replace x by 0, minus 2 into 0, that is equal to, one more step, minus 2 into 0, that is equal to 0. This is g dot f of x when x less than 0. Case number 1 over. Now case number 2. Here also I am going to find g dot f. Introduce x. G within bracket f of x. Here when x greater than or equal to 0. That is equal to g, right, as it is. When x greater than or equal to 0, what is f of x? X greater than or equal to 0. X greater than or equal to 0. F of x, that is equal to 2x. Okay. So this can be replaced by 2x. That is equal to, here listen, this is greater than or equal to 0. Full of positive numbers. Here 2x there. Now what is the function outside the bracket? G only. Go to G. There also have to consider greater than or equal to 0 only. Right? For greater than or equal to 0, what is g of x? 0. G of x, that is equal to 0. That means whatever the value of x, g of x value is 0. Particularly for x greater than or equal to 0. So here 2x also 0. For example, I consider 5. x greater than or equal to 0, 5 will be there. G of 5 that is equal to 0. Suppose if we replace x by 5 here, 2 5s are 10. 10 also in this interval, correct? X greater than or equal to 0, 10 will be there. G of 10 also 0. So even g of 2x that is equal to 0. In both the cases we have proved x less than 0 for greater than or equal to 0, g dot f of x that is equal to 0. Now subdivision number 2. Listen carefully. Now case number 1. When x less than 0, I am going to find f dot g, second subdivision. F dot g as usual introduce x, f within bracket g of x that is equal to f less than 0 g of x value, less than 0 0 g of x, less than 0 g of x is minus 2x, right? Minus 2x. So less than 0 means negative. Remember, for your reference I have written negative, full of negative numbers. X value full of negative numbers. That is equal to, outside the bracket we have f. Go to f. You have to consider less than 0. Go to f less than 0. Here f less than 0. What is the value? 0 only. Whatever the value of x here, just a minute, here, even though here x less than 0, but we have minus 2x, I write minus 2x. Minus 2x will be positive. What is the reason? X is negative. Negative into negative number is positive. So this minus 2x becomes positive. So in f we have to consider positive value. See, this one only have to consider, greater than or equal to 0, positive. What is the value? 2x. Here x, here 2x. 2 into the value inside the bracket. 2 into the value inside the bracket, like that. 2 into the value inside the bracket. What is here? Minus 2x. That is equal to minus 4x. Case number 1 over. Okay. Now case number 2. When x greater than or equal to 0, x greater than or equal to 0 means positive. Okay. Now I am going to find f dot g of x that is equal to f of g of x that is equal to f of that g of x for greater than or equal to 0. G of x for greater than or equal to 0, what is the value? 0. You can replace g of x by 0 equals, right. Now greater than or equal to 0, outside the bracket we have f. Go to f, consider greater than or equal to 0. Here f of x that is equal to 2x. 2 into the value inside the bracket. 2 into the value inside the bracket, we can write 2 into the value inside the bracket here. 2 into 0, 0. Okay. Finally, you can write the result. Therefore, g dot f, this is the first subdivision, that is equal to, here we have proved g dot f, we have proved g dot f that is equal to 0 for x less than 0. Even for greater than or equal to 0, g dot f equals 0, right? 0, 0, if x less than 0, if x greater than or equal to 0, and f dot g that is equal to if x less than 0, if x greater than or equal to 0. For less than 0, f dot g that is equal to minus 4x, and for greater than or equal to 0, f dot g that is equal to 0, minus 4x and 0. So book answer, you are given 0 only for f dot g. Our answer is absolutely correct. Book answer is wrong for f dot g. Okay. For proving the book answer is wrong, particularly for f dot g, I take one example you can easily understand. Verification. I am going to find f dot g. F dot g of x that is equal to f of g of x, that is equal to f of what is given, g of x. G of x that is equal to mod x minus x, mod x minus x, that is equal to, outside the bracket we have f. Go to f. So the x should be written as mod x plus x, modulus of the value inside the bracket plus the same value inside the bracket. Outright, modulus plus modulus the value inside the bracket write as it is, plus the same value inside the bracket. Again I tell you what is here, modulus of the value inside the bracket plus the value inside the bracket, modulus of the value inside the bracket plus the value inside the bracket. So with modulus, without modulus, that's all, right? Now for this part only we have to verify, isn't it? X less than 0, I take one negative number. Less than 0 means full of negative numbers. I take minus 3. Okay, when x that is equal to minus 3, f dot g 3 belongs to which is less than 0. Okay, f dot g of minus 3 that is equal to modulus of minus 3 minus x should be replaced by minus 3 plus modulus of x that is equal to modulus of minus 3 minus x that is equal to minus 3, that is equal to modulus of minus 3 that is equal to 3 minus into minus plus 3 plus modulus of minus 3 equal to 3 minus into minus plus 3, that is equal to 3 plus 3 that is 6, modulus of 6 plus 3 plus 3 that is equal to 6, modulus of 6 that is equal to 6 plus 6 that is equal to 12 is the answer. Okay, we can verify whether it is correct or wrong. For x less than 0, what we have proved, minus 4x. What is the value of x here? Minus 3. Replace x by minus 3 here, minus 4 into minus 3 that is equal to 12. Here also we have got 12. So our answer is absolutely correct. This verification only for our reference, no need to write in the examination. Thank you children. Problem number 10 is completed. I will be teaching that problem number 11 in the next video. Thank you children.